Hi, everyone. We only have 3 lessons left for the end of the year. I'm so excited. We can do it, folks. The end is in sight. Today's lesson is properties of tangents. I'm so excited. Everything will be about tangents. Remember, tangent comes from an external point and it touches the circle on one part of its circumference. So in the first picture, we have two tangents, PA and PB, and guess what? If two tangents are drawn to the same circle from an external point, they are congruent. So that means they're the same exact size. So if you look at the first example, we have CB and CD are tangent to circle A, and it says find the value of X. This is real tough, folks. If CB is 15, then that means that X has to be 15 in this case. They have to be the same. They cannot differ from each other because they're congruent. All right, in the next one, we have 3x plus 5, and the other guy is 14. So I'm going to set them equal to each other. And everybody loves a good algebra problem. So now we have 3x equals 9 when I subtract that over, or x is 3. Super fun stuff. Okay, now let's get a little crazy and draw a whole bunch of tangents around a circle, and we're going to find the perimeter. So there's more than one tangent in all of these pictures here. So I'm just going to start on this side here. So I know that this guy is 14. That means this other tangent over here is also 14. Well, this whole segment is 23 and that piece is 14. So that means this tangent over here is 9, which makes this piece 9. Well, now that whole segment is 22.7 and part of it is 9. So this other part has to be 13.17, which then makes this, or 7, sorry, which then makes, what was I thinking? That makes this 13.7. Now, all I have to do is add up the perimeter around there. So I have 23, I have 22.7, and if I add this other guy over here, I have 27.7. So total, it's 73.4 for my perimeter on there. Excuse me, folks. I need some coffee. Okay, that was easy and fun. Let's do another. Okay, so this guy's 13, so that makes this tangent 13. Well, the whole piece was 25, so that means this is 12. So that makes this tangent 12. If I subtract it from 21.8, this is 9.8, which makes this piece 9.8. I already know this little tangent is 4.6, which makes this little tangent over here 4.6. If I just add up around the whole outside of the shape, I end up getting 78.8, and I trust that you could add all those pieces together and get that answer because you're in geometry honors. Not for long, folks. Moving on to algebra 2 honors, some of you. Some of us might come back to geometry. Okay, so we've got common tangents. These are kind of fun. So there's several different situations that could happen. Like you could have two circles and they would not be touching each other. And the most number of tangents you could have would be 4 common tangents. You could have two circles touching each other, and at most there could be 3 common tangents. You could have two circles that intersect each other, and at most there would be 2 common tangents. If you had a circle inside another circle touching it in exactly one spot, you could have 1 tangent. And if you had 2 circles, one smaller than the other, inside of it, like a donut, there's no common tangents. That's so fun. Okay, so now, another fun fact about tangents, because remember today's lesson is all about tangents, is that if you have a tangent that is either drawn to a radius or a diameter of a circle, it's going to be perpendicular at that point of tangency. That totally makes sense. Remember, that's half of a circle. So technically, if I extended this out, that would be like a tangent coming into a diameter, so it's going to make a right angle. So in order to use that fact, we can do things to like prove that the tangent is actually hitting a radius or a diameter. And if we look at this first example, it says, how can you show it has to be tangent? Well, if it's got to be tangent, it's got to be a right angle, and we could use our good friend Pythagorean theorem. Because at this point here, 9 squared plus 12 squared should equal 15 squared. Well, I'm going to do my math on there. I got 81 and 144, and 15 is 225. If I add those together, 225 equals 225. So is it tangent? Yes, it is. And that was fun. Now, the next one says to find this point here. And since it's tangent, it has to be right. So I can use Pythagorean theorem to actually solve for the missing piece. And since I'm in honors, I know that's a special triangle for a Pythagorean triple. It's a 5 for that missing piece. It's 5 squared plus 12 squared equals 13. 5, 12, 13 is a Pythagorean triple. Woo! Let's try some more fun. Okay, so we have PQ is tangent to circle O at P, and SQ is tangent at S, and OQ intersects the circle at O and T and R. Wow, that's a lot of stuff. OP is 15. All right, so this piece is 15. Hey, this guy's 15 too. And guess what, folks? So is this. Because those are radii of the circle, and so is this. So they all have to be equal. I don't know if that's going to help me, but it's fun to fill that in. P to Q is 20. So I know that's 20. And now it says find O to Q. Now remember, if these are tangent, these have to be right angles. So technically, O to Q is my hypotenuse. So I'm going to do 15 squared. Oops, if I can write. Oh my, 15 squared plus 20 squared has to equal x squared. If I do my Pythagorean theorem, in this case, x should come out to be 25. Okay, so now I know from O to Q is 25. They're asking me from S to Q. Well, that's easy because that has to be the same value as Q to P, so it's also 20. And then it's saying from T to Q, oh, well, I know O to Q is 25. I'm going to add this 15 because it's another radius. So that means that has to be 40 for that piece. That was so much fun. Let's try our last example. I'm going to use my eraser to get this stuff off my circle. Hang on a second. It's a little slow. There's like 5 people on a Google Meet in my house. So my internet's slower. Okay, so we've got P to Q is 3x. And S to Q is 5x minus 8. Well, you should be thinking, oh, how fun is that? Those things have to be equal. So 3x equals 5x minus 8. Negative 2x is negative 8, or x is 4. So from P to Q is actually 12. This guy's 12. S to Q better be 12 too, because they have to be the same size. Now, O to S is x plus 1. Oh, well, x was just 4, and 4 to plus 1 is 5. Now I'm going to do from O to Q. Okay. I know this guy's 5. Boop, boop. This guy is 12. And there's a right angle there, so I can do 5 squared plus 12 squared equals x squared. Oh, but I'm in honors, and I know that's a Pythagorean triple. 5, 12, 13 is my value for x. And that concludes our lesson on tangents, friends. Fun. Only 2 more lessons of the year to go. You can do it. Bye.